Hello everyone, this is Lenu. Welcome to Learnwizz. Hope you guys are doing well. In today's video, we are going to discuss the third part of chemical kinetics. Hope you have watched the last video. Hope you enjoyed it and understand the concept related to chemical kinetics. Any doubts, you can comment or you can ask me directly through our Telegram group, WhatsApp group, Instagram, etc. And if you have any suggestions, you have to post it on the comment box. Okay, don't forget to subscribe our channel, hit the bell icon. You have to share it with your friends. Okay, in today's video, we are going to discuss about, first of all, pseudo first order reactions. Pseudo first order reaction. So what is pseudo means? It's a false, right? That is, the order can be altered sometimes by certain conditions. Okay, sometimes consider the chemical reaction between two substances when one reactant is excess. For example, just take this CH3 COO C2H5 plus water. Okay, what is this reaction? You know that this reaction, right? Esterification, hydrolysis of ester, right? Yes, water. We are adding water in the presence of acid. You will be getting what? CH3COH, acetic acid, plus C2H5OH, alcohol. So this is hydrolysis of ester. This is the first reaction, hydrolysis of. So the concentration of water here does not get altered much during the reaction. Okay, so while writing the rate of the reaction, we will be writing the constant into reactant, right? Concentration of the reactant. If the concentration of the water is not altered too much, so we can write only this rate is dependent on what? This ester only. Okay, actually it appears to be a second order reaction. Okay, second order reaction, right? But what is it actually? It is actually behaves as a first order reaction, as the reactant water has no effect. Okay, not much effect, not much get altered during this reaction. So this is a first order reaction, appears to be higher order, right? So this is called as pseudo first order reaction. One more example we have to study is inversion of cane sugar. Inversion of cane sugar. So here you can see cane sugar C12, C12H22 and O11. Water we have to take in excess. Okay. Then you will be getting glucose and fructose. O6 plus C6H12O6. And you will be getting this rate is equal to K, right, constant into O11. That means here this is appears to be higher order, second order reaction, but actually it is a what? It is a first order reaction. That is called as what? Pseudo first order reaction. Okay. So these are the two examples: hydrolysis of ester as well as what? Inversion of cane sugar. Very important. You have to study this pseudo first order reaction. Actually, the reactions which appears to be higher order but behaves as a first order like reaction, that is called as what? Pseudo first order reaction. Next is very important topic you have to study is the factors affecting the rate of the reaction. Factors affecting. So there are 5 factors that affect the rate of the reaction. First one is nature of reactants. That is the physical state of the reactants. It may be physical state or it may be the particle size. Okay, and that means particle size means surface area, right? Yes, it may be surface area or the chemical nature of the reactants that affect the what rate of a chemical reaction. And if the reactants are in gaseous phase or in solution, if the substance reactants are in solution, the rate of the reaction is higher rate for the reaction. Okay, and if the surface area increases, what will happen? surface area increases, reaction rate also increases, right? Higher the rate. So the physical state of the reaction, the surface area, chemical nature of the reactant, all these affect the rate of the chemical reaction. Then the second one is concentration of the reactant. Concentration. As the concentration increases, what will happen? As the concentration increases, the rate also increases. Why? As the concentration increases, more number of particles will be there, right? So there will be more collisions. So more successive collision will be there. So automatically rate will increase. Next is temperature. Temperature of the reaction. What is happening when we increase the temperature? What will happen? More particles will get more energy, right? They try to move more faster. So more collisions, right? So automatically what will happen? Increases the rate. Temperature increases, rate also increases. Actually, the rate of this reaction increases 3 times. Okay, 3 times when temperature is increased by 10%, 10 degree. Okay, sorry, 10 degree. If we increase the temperature from 10 to 20 degrees Celsius, there is a chance of increase in the rate 2 to 3 times from the original rate. Okay, that is a very important point. Okay, then effect of catalyst. Okay, effect of catalyst. What is effect of catalyst? Catalyst is a substance we know that alters the rate of the reaction without itself undergoing any chemical change, right? It is not undergoing any permanent chemical change. Okay, so that it is not never used up in the reaction. It can only alter the rate of the reaction. Okay, now we have to study a temperature coefficient, temperature dependence of rate of the reaction. Here we are discussing about a small equation, Arrhenius equation. Okay, temperature dependence. What is that? Which equation we have to study? Very important. Sure questions will be the Arrhenius equation. Arrhenius equation. Okay. Yes. So study this equation. A K is equal to A e raised to minus EA by RT. First of all, you should know what are the things. What is A? What is K? Yeah, it is rate constant, right? Yes. So this rate constant and A is called as Arrhenius factor. Okay, Arrhenius factor. So this is Arrhenius equation. So Arrhenius factor should be there, right? It is also called as one more name, that is frequency factor. Frequency factor. And what is the exponential, right? What is EA? Yes, it is activation energy. Activation energy. And what is T? T is the temperature. Okay. Yes. And this A is the Arrhenius factor, yeah, frequency factor, and it is before the exponential, right? So we can also call it as what? Pre-exponential factor. Pre-exponential factor. Pre-exponential factor. So must know the terms related to this equation. Rate constant is equal to A e raised to minus EA by RT. E is the activation energy. R is the, what is R? It is the universal constant. Okay. Then T is the absolute temperature and A is the Arrhenius factor. And this term together, okay, this is frequency factor, Arrhenius factor A, and this term together called as Boltzmann factor. Okay, that is E raised to minus EA by RT is together called as Boltzmann factor. Boltzmann factor. Now let us convert this equation. So when this equation is like this, it is very difficult to find out, right? Because exponential, right? We are not, we have should use via calculator, right? For this purpose. So it is very difficult. So you have to make it a useful form. What will I do? How will you remove that exponential? We have to take logarithm on both sides. So I'm going to take ln on both sides. Ln k is equal to ln a minus ea by rt. Okay. Yes. And logarithm to the base 10. Log k is equal to log a minus ea by 2.303 rt. Okay. And yes, this is in the form of what? Y equal to mx plus c. So we can draw a graph, right? Yes. What graph we will draw? Log k against 1 by t. Okay. Log k against 1 by t. You will be getting this m as minus ea by 2.303 r and intercept as log a. So it is a negative slope. You have to draw a graph like this. And slope is negative ea by 2.303 r, and this intercept, this is called as what? Log a. So this is one of the graph that is related to Arrhenius equation. So when you know the equation, actual equation, you can take logarithm on both sides. You will be getting what? This, you will be getting the formula of y equal to mx plus c. So you can easily find out the slope here. Okay. And one more thing, you can take this log if there is two rate constant and two temperature. Okay. So what will you do? Log k2 by k1 is equal to ea by 2.303 r t2 minus t1 by t1 t2. So that is, if K1 and K2 are the rate constant of the reactions at temperature T1 and T2. So you can find EA, or you will be asked to find the activation energy. So you have to use this equation. Okay. So you'll be given, there is, you can see the logarithm here. You will get a simple value of the log. So you can easily work out this. So this is very important. Arrhenius equation is very, very important. Okay. And let us do some problems related to this. Okay. Yes. See, imagine a first order reaction. A first order reaction is 50% complete in 30 minutes. Okay. And that is 30 minutes at temperature is given 27 degrees Celsius, and the first order reaction is 50% complete in 30 minutes and 25% at 27 degrees Celsius, and in 10 minutes at 47 degrees Celsius. Find EA. So we know the equation first order, right? 50% complete means what? T half, right? Half life period. And we know that T half is equal to 0.693 by K. That is the first order reaction T half equation, right? So you will be getting what is T1 by T2, that is equal to K2 by K1. Using the relation between T and K, you will be getting 30 by 10 is equal to 3. Yeah, now you get this. Then according to Arrhenius equation, EA is equal to log K2 by K1 times 2.303 r T1 T2 over T2 minus T1. Okay, temperature you have to convert it into Kelvin scale. So it will become 300 and 320. Okay, by taking the difference, you will be getting 20. And K2 by K1, you already get 3. So log 3, right? So that is log 3 times 2.303 r. We have taken r as what? 8.314. Okay, then 20 here. Here you have to multiply temperature. What is the temperature? 300 and 304. Just find out the value and put your answer in the chat box. Okay. Yes. So this type of questions will be coming from Arrhenius equation. Okay. So you must know what is the concept of all this. Arrhenius equation is very important. Okay. Yes. Now let us practice some questions related to this topic. Okay. That is, first question is, if K is the rate constant of a first order reaction, then the time required for 99.9 percentage completion of the reaction you have to find. Okay, we know this is a first order reaction. Then write down its equation for time. You have to complete time. You have to find the time. So T is equal to 2.303 by K log final initial concentration. You have to take 100%. So 100 and final 99.9 percentage complete means 100 minus 99.9, that is 0.1 percentage. Okay, so you will be getting what? 2.303 by K. K is not given, it is given as K itself. Okay, and what is 100 by 0.1? That is equal to log. So 100 by 0.1 is equal to what? How will you make it? Okay, let us do 100 and 0.1, right? So you have to remove this 0.1. So what you have to do? You have to multiply both denominator and numerator by 10. Okay, so here you will be getting 1000 over 1. 1000 means 10 cube. Okay, that means log 10 cube, that is equal to 3 log 10. Log 10 is equal to 1. So we'll be getting a 3 value. Understand? So you will get the answer 3 times 2.303 by K. That is the answer. Okay. So this is the method we are finding. Okay. And now moving to the next question. If for a reaction, to a giving products. Okay, and rate is given. Rate is equal to K times A raised to 2. Okay, if the value of concentration of A is doubled, the value of rate constant, okay, value of the rate constant will be. Very important question. Okay, so what will you do when you understand the concentration of A is doubling? So you will directly put, instead of A, you will put 2A, right? So you'll be getting what? You'll be getting 2 square, that is 4. Okay, so automatically you will do this. Yes, I'll make you understand. K, you will write like 2A, the all square. You will be getting 4. K is here, 4 concentration of A, and this will be in the options. Okay, so we will directly mark that. And what is the question? The question is not about the rate. Okay, what is the question? Value of the rate constant is the question. So you will get wrong when you write it as OK. Okay, what you have to do? Here rate constant is independent, right? We have studied that rate constant is independent of the concentration. So the rate constant is having no change. So here same rate constant is same. Rate constant is same. Rate is increasing 4 times. That is correct. But rate constant is having no change. Okay, don't be confused about the answer. Okay. Yes. Moving to the next question. The equation is given 2A plus B equilibrium with C plus D. And it is given rate. Its rate equation is given that K A raised to half. Okay, A raised to half and B. And it is saying that A concentration of A is doubled. Okay, and B concentration of B is decreased by 1/2. Here the question is, we have to find the rate of reaction. change. Rate of reaction change you have to find. So here automatically rate is asked. So you have to apply in the equation. Rate is equal to, new rate is equal to K 2A raised to half and B is half, right? B by, so what do you get? Yeah, 2 raised to half means what? 1 by 2, right? Yes, 1 by 2 means root to 2, right? Yes, so you can write K root to 2 and you have to take this 1 by 2 concentration of A and concentration of B. A raised to 1 by 2 is there. Root 2 by 2. In this 2 we can write like root to 2 times root to 2, that is 2, right? Cancel, cancel, we'll be getting 1 by root to 2. So the new rate is equal to 1 by root to 2 times the initial rate, that is K A raised to 1 by 2 B. This is the method. So these are simple questions. You have to understand the concept very well. So it will be very easy for you guys. Okay. Moving to the next question. Activation energy. Okay. Activation energy. A question related to activation energy is given 64 joules. Okay. A2 plus B2 giving 2AB. Okay. The activation energy of this equation, this reaction is given 64 kilojoules. Okay. And you are asked to find the activation energy of half A2 plus half B2 giving AB. Okay. No other information is given. Just an equation is given. Activation energy of that is given. And the same equation is throughout divided by 1 by half, right? So throughout divided by 2, you will be getting some another equation. And there is only stoichiometry difference, right? Okay. So what is the new activation energy? It is same as 64 because activation energy does not depends on stoichiometry. That is the thing you have to remember. Okay, so activation energy does not depend on stoichiometry. So this is also very important, like rate constant. And one more thing, one more question we will do. The plot for, we have studied a plot of plot for which, a different question. Okay, slope is given minus EA by R. What is that plot? I mean, the question means what is the plot where what is X and Y axis? Okay, so if you know this EA, just think about the activation energy equation, Arrhenius equation, and what is the plot we discussed in that equation? It is in the form of ln K is equal to, okay, ln A, right, minus EA by R, okay, EA by RT, right? So here there is no 2.303 here in this slope, right? That means it is a natural logarithm. So you have to plot log K against 1 by T. Hope you understand this equation. How this equation is changing depending upon the question, we have to understand that concept very well. Okay. Yes. Hope you understand the concept of chemical kinetics, right? Any doubts, you can ask me in the comment box or directly to the Telegram or Instagram page. If you enjoy the video and find it useful, please share this video to your friends. Okay, I would like to hear from you. Any comments you have. If you are able to understand the concept very well, please subscribe our channel and like button. Okay, hit the bell icon too. Okay, so in the next video I will be with you with a new topic. Okay, till then stay curious, keep learning. We will see in the next video. Till then, bye. Thank you.